Yes, absolutely. Yeah. Big shit up. You want to get have you been on this company 6 weeks? It's very and make some shit up. Well, no, I mean, it's like, get some patents filed. You'll see, you get a patent. Found attached. TBD. I know like. So is Margaret on?
Yeah, remote control of them. What's wrong, George? Rock. Oh, right. He only knows where the rock. Oh, there he is. Sorry.
Yeah, I'm into the thing. Yeah. Well, setting something up.
I'm connected to something, it knows it's there.
Yeah. And it's under this. I saw one. Take it to it's in the code. I take it. That's a number. Oh, you found it. Perfect.
Oh, we found it.
We're not changing it yet.
Hey, there we go. Right.
So people like me would like, how about this? They can't do so it's a likely situation.
God love from you.
Why do you ask if there's?
Well, I think he's watching next question, so we get video recorded.
Are you gonna post the URL for this on, as a comment to meetup?
I can't post comments on it.
No,
I can send it to the link.
I don't have my laptop, so I can't. It's the only device that knows my login credentials. Okay. Maybe one of these guys.
I can send you guys the link.
Preferably not a bad.
Are you able to log into meetup from here?
I can't right now, but maybe.
Give it a shot.
Does anyone have access to me?
I left my laptop at home, so I can't.
What's wrong?
Do you have access to meetup from here?
If I can signal, yeah.
Okay.
What?
The URL for the
Live stream.
We should post that.
Can put in the comments.
The problem is, everybody talks to Ron all evening, and then when it's time to go.
Because you look like Cisco.
There it is. Adrian, did you hear that? She said I looked like a Cisco person.
Well, you were.
But she said she knew, but she said I looked like a Cisco person.
Cisco Ron?
Come on, man.
How
You know the
long
team?
that will forever be your name.
What do you mean?
It's
Like
been 13 years.
Okay. That's my password one of these years. I have to be so easy.
Sweet.
Whoa.
Green screen.
Are you sharing to the event?
Somehow you got one.
Oh, why is it 2 minutes?
That green tape over. You should have a beer.
We'll be there for a second.
Okay.
Yeah, that's what they call it.
Do you know what's going
We use BI to look into files.
You just lost your server.
And you use BI creates then you say, how do you it's just me do. Well, either use the initial one is too small. I use less, which is better.
It's working.
Oh, yeah.
They're back. Is it
You're flashing it, then signal it.
Yeah, I see it.
This box is searching.
A small script in a way to handle these notes. So I can search, I can, it will show you which file.
We're on. Live.
We just have to get a presentation. Just do it off. There's no demo.
Demo is all I asked.
I'll just send you
Very fun. Can you check? Can you check second? Your time?
You don't want to do that?
Yep. Yeah, it's there.
That'll work great.
Long you don't touch it, right?
I guess. Let's see. It's functional.
Hey, good evening and welcome to the July, welcome to the July 2025 meeting of BayLISA, the Bay Area Large Installation Systems Administration User Group. My name is Mark Roser, I'm the president of BayLISA. Here today we also have fellow BayLISA board members Guy Purcell, Peter Downs, Ron Pagani, and our Cisco representative and board member Adrian. BayLISA is held on the third Thursday of every month, and its meetings are open to the public. We are a membership organization, so we do encourage people to join, but it's not required. Membership fees enable us to pay for various organizational expenses, like meetup.com, refreshments, and such, so that we continue to bring you the best speakers and to present interesting and relevant topics. If you or your organization would like to become a member, please speak with myself or one of the board members after the presentation or online. BayLISA would like to thank Cisco for supporting BayLISA by arranging for spaces to hold our events. Yay! Without corporate sponsorship, these would be much harder to hold. Please be respectful of facilities and remember to clean up after yourselves. I don't believe there's Wi-Fi still here in Gobble. No, sorry. Some sites do, we don't have it. BayLISA is a volunteer organization, and as such, the board is always looking for new volunteers. If you enjoy these talks, we encourage you to give back to the community and help. It's not hard work, but many hands make the lift easier. The board meets on the first Tuesday of the month to make plans for the general meetings and discuss topics and speakers, and to make BayLISA better. Above all else, though, finding speakers is the most important task for the board. So even if you don't have time to volunteer, we're always interested to know what you want to hear at future events. Maybe you have a subject you'd like to hear more about, or maybe there's a subject you can speak to the group on. If you have a project or experience you would like to, just again, find myself or one of the board members, or drop us a message on the meetup.com site. We do typically reserve some time at the beginning of announcements, at the beginning of the meeting for announcements, I'm sorry. So to start off, are there any board members with announcements? No, check. We typically leave a little bit of time for job announcements, so maybe you're looking for a job or your organization is looking for people to hire for a job. If you have such, you're welcome to raise your hand and you can speak to the group and to the online group. Oh, hey,
Okay.
speak loud. Do you have a mic?
I'm building an indoor robot, so I need infra people. Anybody interested in that?
We're from infrastructure for building robots.
To remote operate a robot.
Road operated robot. You're saying, get your hand raised?
Oh, yeah. Hi, I'm Trevor. I just graduated college. I am looking for a job and I like to do back-end stuff. So if that sounds interesting to you, then we should get in contact. Thank you very much.
So we have a new college graduate named Trevor who's looking for an entry-level position. If you know something, post it on the meetup.com site and we will get your message to Trevor. We'd like to keep you informed of upcoming interesting tech events going on around the Bay Area. Unfortunately, I don't have a whole lot this month that I know of going on. Open Source is coming up this weekend up in San Francisco. 2 days of all sorts of things, tech events. Oh,
I think the Vintage Computer Festival West is next month.
Vintage Computer Festival West is next month.
Computer history.
If you're not familiar with that, that's they bring a lot of old tech hardware and people talk about the good old days of tech, and it's a lot of fun and hardware swap meets and stuff like that. Usenix Enigma conference is no more, but this year the 34th Usenix Security Symposium will start at Enigma at Usenix Security Track. This is held August 13th to 15th to be held in Seattle this year. The Security Symposium brings together researchers, practitioners, programmers, and others interested in the latest advances in the security and privacy of computer systems and networks. Early bird tickets may still be on sale, but hit up your security vendors if you're interested in going and tell your boss you want to go. Maker Faire returns again this year in September. Billed as the world's largest show and tell, the fair combines DIY worlds of science, tech, music, arts and crafts, food, and more. And the weekend that's billed as the world's largest show and tell. It's held up again in Mare Island at the Naval Shipyard in Vallejo. And I believe early bird prices of that have ended, but they still have some discounts if you look on their site as well. This is a really great event if you haven't gone there, if you're interested in tech. Even if you're like a little interested in tech, but maybe you have nieces, nephews, sons, daughters, and want to get them interested. I've taken my daughter since she was like, 1 year old, and she loves that thing. Both my daughters, just their eyes light up when they see it. It's like school will teach you how to do things and possibly, reasons behind it, but why you do that. Why do you have to learn these things? What's cool about it? Otherwise, you can do this too. And it's really great event. Okay, so before we get started, we ask you to keep your phones on silent or vibrate. Many of us are part of on-call rotations, and we will understand if you get paid, but please, if you have to take calls to minimize disruptions, step outside to do so. Okay, so the size and speed at which one's data systems can ingest information, process it, and present it in an actionable form is almost always something businesses are trying to improve on. More data is better, but more data typically means slower time to results. And for almost all businesses, slower means lost time, possibly customers, and at worst, lost sales. So how do you increase your data intake, but keep processing time constant, or at least keep it beaten down? Real-time analytics systems propose to help with that by leveraging the act of ingesting data itself as a mechanism to process it at the same time through streaming platforms and event-driven architectures. So to help us on our journey to bigger data and faster results, tonight, please help me welcome Ryan Hill, a solutions architect at Cloudera, with his talk, Building a Real-Time Analytics Platform from Open Source Components.
Good evening. I don't know if these things are on, let me know if they're not. So I'm a solutions architect. I have recently been relabeled as a research engineer. I have been kicking around machine learning and for 20 years or so, and that's become in vogue, and so that became the dominant skill set. So here we are. But for Cloudera, I've been there for 4 years, working on all the things that are in the Cloudera stack, various customers, and building the big data solutions that everybody loves. And so now we're combining. Oh, and I'm the one. I'm not on call, but
You have to see yourself out.
In any case, tonight, so this was more of an idea. Do we need this?
Oh, yeah.
Okay. So this was more of an idea than something that came together over a long period of time with lots of planning and implementation strategy or anything like that. We just kind of started talking about this concept and put the pieces kind of in the same domain, and then came up with a concept that we could maybe implement. So I'm going to kind of walk through the background. So Cloudera has a thing called Cloudera Streaming Analytics and the SQL Stream Builder is where the SSB was an acquisition. So it came into the platform and was integrated some time ago. And it kind of sat unloved on the side for a long time. And it's just in the last 2 years, 2.5 years, that it's picked up a lot of momentum. And part of that is the interest or capability to do these language text to SQL type implementation. So you can imagine if you're defining streams in SQL and now you can just speak what you want to see in the output of the streams, then that's going to also, we got the emergence of feature stores. So Cloudera has a lot of components in the stack. There are great feature stores in the world. I'll talk about Feast a little bit. But the idea is to avoid adding yet another component to the stack. To get that done, we could take the core of this CSA product, based on Flink and other things, and then go ahead and add Apache Pinot. So Apache Pinot is also pretty well known. LinkedIn, lots of other contributors like Uber, has amazing indexing capabilities. I'll get to explaining why that's relevant. And this is an implementation roadmap. So we have a lot of pieces and like IAC repositories that set up the infrastructure and then other things that you kind of hand wave and manually put things together. So it's not done, but I think there's a reasonable timeline to getting. And then the other parts that are more proprietary, they are done pretty well. And that'll be kind of the automation side of things. So kind of the idea, the motivation was that, we have this product, people can buy it, it's great, you can try it. Cloudera, a lot of times people out who are using the solution, either paying for, corporate support, that kind of thing, and come to it from the source on-ramp to just get started. We really have a system. It's kind of awful, and there's no need to be so stream. If there's an existing SQL, streaming API integration tool out there, that'd be good. But not aware. So the idea is that we need, I think, personally, this is not Cloudera talking, so I think personally that we could use a open source on-ramp to understanding how all these pieces fit together, so that people can try it on their own, so that I can use it on my own, that's how it works. And then potentially determine if there's community interest. That'd be great. Kubernetes. So traditionally Cloudera, distributed computing for a long time, but kind of new to Kubernetes for the last 3-4 years, really since I've been there. That's been the on-ramp. So I'm taking the approach of kind of going Kubernetes first and assuming that everything that I deploy, like it or not, will be deployed in Kubernetes first or at some point. And so that's also part of the motivation, is trying to go top to bottom and see what can be optimized for that form factor and put it all together. And there's also this idea, so Apache Pinot has the configuration recommendation engine. So not all Apache projects are great at having great configurations out of the box. It's usually a bit of a mystery or purposefully obtuse. I don't know, obscure. I don't know how to make sense of that, but things like timescale do a great job of having a script that looks at the database, decides what kind of hardware it's running on, and tells you exactly what the configuration should be for a workload. That's fantastic. Pinot has this as well. So it's not perfect, but maybe in combination with other things, it could be a way to dynamically optimize the entire stack. So at least it's a good job. CSA architecture. So again, this motivation, these are all pieces that get put together with this Cloudera product. And so, yeah, you've got the kind of usual stuff on the left, usual stuff on the right, but then you have materialized views. So you think about all the sources that are coming together, creating these streams, connecting to whatever you want, you have to be easy in there. You put those together and you want to define an API. So I'm going to process the streams, I'm going to write a Flink application, deploy that. That Flink application is going to do transforms on the existing streaming data, new streams, and then link those together with actually outside data sources. And then finally, either put them to a sync, which is difficult, or create an API that is backed by materialized views for performance reasons. So materialized views are implemented with Postgres. It's a great platform. It scales really well. It's very performant, but we definitely, in the types of deployments that we do, run up against the wall really quickly on Postgres materialized views as kind of the core way to service data performance. Hence,
Hi, could you blow it down a little bit, that last slide? Is there a way to maybe zoom in on the screen somehow?
I am so committed to doing everything in my terminal now.
Okay. I'm just saying.
Yeah, no, I was fascinated that I could render any images whatsoever in the terminal. That I had to do that. This one also, I'm sorry, I can't really blow that up in here. It's some of this. So this is the core of that, the SQL stream builder. So the idea here is that you can just define in SQL what you want your API to look like. If you're used to like GraphQL, you know, you can have resolvers in there that are mapping from what you have to the shape of the data that you want to expose in the API. In this case, we're doing that with just SQL, creating the REST endpoint. So not too many components. There's a reference here to the ARM Resource Manager that doesn't play without Kubernetes in the old way. We now also have Cloudera has a Kubernetes operator for CSA, and so it's been adapted into the Kubernetes world, so you can deploy it on a typical base cluster or in a standalone Kubernetes environment. So both of those options are available, and that's also part of the motivation for the project is having kind of a uniform distribution of software and different form factors. It's really kind of interesting. So Flink, is everybody familiar with Flink? I've been throwing this word around. I didn't know it before I joined DataStax. So
What is Flink, Ryan?
what is Flink? So we've got two streaming things in the mix. One is Kafka, and I'll just kind of give you my impression. You can actually do a lot of things with both and make a lot of sense, but I think of it as Kafka is kind of like the bus, the message bus that everything goes through. That's my streams. My topics are the kind of the source of truth for information flowing through the system. Flink is extremely low latency, not as ubiquitous, but it has the ability for me as a programmer to build an application that understands streams that are flowing through Flink, and if you know Storm. So there's a pathway to get from kind of a Storm stream topology, what they used to call it, but these flows of streaming sources the same with different nodes linking together and potentially hydrating them with extra information. Flink is, I would call it the new version of that. So it's a little more robust. It's got an active community, a lot of large-scale deployments. And as a programmer, I can write an application and deploy it to the system that understands the streams. And one of the abstractions over the stream is SQL. So the product that makes up SSD is moving in the direction of just using standard SQL as the definition of the way to cobble together your streams in a way that creates APIs. If that makes sense. So stream or the Flink is kind of the substrate that all of that logic executes within. And Flink has all the primitives like windowing, time aggregations and temporal joins, all of those primitive operators that are needed to put the stream together. Flink handles all of them. Thoughts? Questions?
How often when you refresh?
That's a good question.
Ryan,
Oh, how often is the materialized view refreshed? Everything is configurable. And the goal is to keep it as current as possible. So like in this implementation, you're kind of adding to the materialized view, and there's a feature in Postgres that will let the materialized view refresh as fast as it can. You always get a consistent output, but it's doing that also behind the scenes to try to keep the materialized view in good shape. And so there's some congruence there between how Apache Pinot does that and how we expect it to happen in Postgres. So for other situations, I might have done an on request and trigger like a refresh of the materialized view request so the user gets data immediately, and then the materialized view gets hydrated behind the scene or updated behind the scenes. In this case, the idea is to keep it short as possible. Flink is extremely low latency end to end. There's probably some chart out there showing Kafka on one side and something like Spark streaming on another side. I might have made a chart showing how the latency is different between the platforms. And Flink is there like an order of magnitude lower latency end to end than like Spark streaming. And this thing here, applications. We got the user. So go ahead.
So in the previous slide, you have a multi-layer sample data. So what is the usage of that? This mainly for, verifying the result.
And which one were you asking? Populate what?
Produce the sample data.
So, all right. So the flow of events, it's kind of hard to see exactly from the arrows. And I didn't actually make this image, but fundamentally, like Kafka is in the bus, and so everything kind of goes in and out of Kafka. Sample data in this context, I'm actually not sure what the sampling is. That is a good point.
Those arrows need to be bi-directional.
Sampling is here, but if you're using sample data as a way of verifying, there will be a different. Similar but different.
That's a good question.
Maybe this is a ML in Chrome.
No one has ever asked that question.
Welcome to data.
Yeah. So I'm going to say that there is a side channel of sampled data, sampled out of the materialized view stream, that goes back into that. There's an IDE that comes along with, I'll show this in a bit. So there's an IDE that comes along with it. I'm betting, actually, producing sample data is actually what populates the kind of the preview mode of the IDE. So if you go to a definition of a view within that, it's actually routing. It looks like it's routing through the materialized engine back into a topic that can be read by the IDE. And so if I say, what's in this view, what's in this table, that's where it gets that information. Good call. I'm reasonably confident in that answer. Concept. So the feature store is, I don't know if it's the latest thing. It kind of was the latest thing for a while. It doesn't come up as much as it did a few years ago, but it's extremely useful as a concept. So if I'm doing these machine learning, like traditional machine learning or kind of advanced AI things, it's extremely important to have not just the shape of the API, the latest data, lowest latency, all of those things, but also snapshots and a way to reference the data as it was when I trained the models or put together a data set for some downstream user or et cetera, et cetera. So the feast concept, I think it's pretty popular, it's pretty effective, but it's yet another thing to put into the platform. So I'm hoping that I can actually use the STP construct as a way to avoid growing the footprint. It's great if you have it, but there's no reason to invite like another component in the stack. So the couple of capabilities I would say that are needed are going to be, so everything in feast has a timestamp, so it has to be temporal in nature. I could be wrong about that, but it's one page anyway, documentation. The idea being that you can get an understanding of where the data stream was at the time you trained the model from your online features. So that's the concept. So we have the primitives in SSB and Flink and hopefully Pinot to do exactly that. So we should be able to capture everything. Run it through Flink. Flink has multiple data sources. And one of those things could be Apache Pinot. So at this stage, I think I have all the components that I need to put together an effective feature store without introducing a new, oh, that's probably not. So this is even harder to read. I'm sorry about that. So this is the transformation of this earlier hard to read slide with some proprietary things in it, like the SQL streaming engine, through to an update that gets rid of the SQL streaming engine. We don't need the IPE features in this context. We're really just focused on the plumbing. So your user now is concerned with actually creating a natural language definition of the features and putting that through an agent that knows how to translate natural language into SQL of some syntax. I've implemented with Spark SQL and Flink SQL. So this is something that's known to work well. So generating the SQL, we need to put that within I prefer to use the application construct. That's kind of the way forward for Flink. So there's a little bit of templating and source code generation and deployment there. It's a little bit of plumbing, but fundamentally, the natural language is what's translated into the meat of the application. So that goes into an executable that can be deployed in Flink. Unicorn. So this is another component out of the Cloudera stack. It's very popular. It's awkwardly named. I think that's the biggest detraction from Unicorn. But it has a lot of capabilities that are interesting to people coming from the Yarn legacy community. So Yarn has a lot of, especially with the Yarn queue manager, which is kind of new, but has a lot of control over how the resources in a cluster are sliced and allocated to jobs and users and groups, et cetera. So there's hierarchical queues and lots of complexity about how you can configure resource stealing from adjacent queues and things like that to get through some vector of jobs that have been queued up to run on some finite cluster of resources. It's a constant struggle coming from cloud first development where if you pay for it, it'll get done, to a fixed set of physical computing resources. We run into that quite a bit. So the Unicorn scheduler helps put together the logic to manage fixed computing resources underneath the very dynamic Kubernetes orchestration. So I consider that to be part of this implementation. Again, a lot of small text, but fundamentally the Flink streaming is the core of the application. So everything that is intrinsically logical and does the transformations living in Flink, and it needs to be sent back into Kafka. So Kafka is kind of the message bus, and that's kind of there in the middle. So Apache Pinot has the ability to sync from Kafka, but it needs to know what to sync and when. And so the application around Flink that hydrates Flink actually needs to be able to configure the Pinot sync. So there's a little bit of magic that happens there, but ultimately, when you create the tables, there needs to be a push down from the text to SQL through down into what you intend to make available through Pinot indexing. So that's another bit of fun. Postgres is still around because that's the core metadata database. That's for everything for administration. That's for there's some metrics and things like that that go in there. And then everybody. So there's an MCP server. It's a very popular way to abstract pretty much any reason. Someone called it a universal plugin mechanism. I found it to be very effective. So that seems like an easy way for me to get a cheap developer-focused UI from the, what do they call that? The MCP inspector. I don't know if anyone's seen this. It's a nice, simple, very simple UI that exposes just the tools and resources and other things that MCP knows about. And it's also then made available to things in Cloudera stack that actually support remote SSE type MCP services, and hopefully other things as well. So that's the concept. Thoughts? Yes?
So the mention of the MCP server is basically saying, showing where the MCP server fits into the architecture. Is that the point?
That is. And the idea here is that, it's great that we've indexed things, and that's intended to be our API layer. The way to expose a universal API is through MCP. Go ahead. Oh, no, please.
I had a different question. I was going to ask you what Apache was.
Oh, yeah. I could see how that is information I should cover. So Apache Pinot, again, project out of LinkedIn. It is a database. It is a data store. It has a SQL layer. It has a SQL engine. It has a lot of facilities for managing large-scale data across many nodes. So it's a distributed storage engine. It was also new to me until pretty recently, like in the last 3 months or so. But once you start looking around for it, it seems to be pretty ubiquitous. It has a good community. It has a lot of contributors that are active and coming up with new designs. One of the core capabilities that it has a set of indexes that it can create. I don't know if there's a good overview. This I can blow up a little bit. So aside from all the data storage capabilities that it has, I'm mostly interested in the indexing capabilities. So obviously there's tables, there's storage, there's it's organized on things segments. So there's a lot of like right path plumbing that's unique and interesting for Pinot. It's very high performance from a writer, multi-writer, high write volume and velocity perspective. So it's very effective in that regard. I have a lot of things that can do that in the stack. So probably too many. What I don't have a good solution for is to be able to index these index the storage layer with as many options as Pinot has. So bloom filter, this is a common thing. Pretty simple. It has a strict test, so it has a test that will tell you if it's definitely in this collection in this segment or not, and so it allows for like very quick recall, things like that. I haven't gotten into some of these, but I'm extremely interested in the geospatial capabilities. So Cloudera doesn't have. We have some geospatial things, and there's certainly geospatial projects in the Apache, under the Apache umbrella. But there's not a trivial way to do a geospatial index on top of things that we typically see. So I don't have a good out-of-the-box solution for that. So that happened to be very interesting for certain projects. And so the ability to create a geospatial informed index on top of arbitrary output data is very interesting. Gives me that. JSON ranges, pretty obvious. Star tree is the kind of a famous indexing option. I don't know if this picture is going to come up. I don't even know what's in this picture. Maybe it's not going to come up over. Well, it's a video. So one of the original use case for Pinot was, I believe who has looked at my page in LinkedIn. So I think they built this internally at one point, and it was very interesting. They had a few users, and they said, okay, let's make the entire world able to see who has looked at my page recently. And so then the scaling problem that invited created the need to build a multi-column, super scalable indexing platform. So the Star Tree Index was probably the jumping off point for all of the other capabilities that have been built around. I actually don't have an out-of-the-box need for the Star Tree Index myself. I'm just happy to have it. Time series has time-stamped indexing. Again, no pictures. Not doing pictures today. But this is also something. So Cloudera has had Apache Druid. A lot of people still use Druid. There's half a dozen time series type solutions that I tend to run across. But there's not a really great option just out of the box from what we have. So being able to do even rudimentary timestamp based indexing and retrieval is extremely valuable stuff. So when you say, what is Pinot, what does it do? I'm thinking all about the indexes. So does that make sense? Feel free to, okay. And again, a normal person would have made slides to cover exactly that. Let's go back here. So I think I at least said everything that this slide implies. If there's no more questions, I'll go on to the next difficult to read slide. So one of the key pieces of this setup is the ability to, again, just use natural language to generate the SQL that gets wrapped in an application deployed with them. First implementation of this is with Spark. So you can imagine a chat interface where someone just wants to be able to ask questions, and that pulls back information they've loaded from PDFs, all the usual chatbot type things. One thing that the chatbot and transformers in general are not good at doing is aggregating and analyzing structured information out of database tables, any other kind of like quantitative source that has a lot of implicit information in just how the data is structured, it fails completely. However, so there's an agents platform. So I used small agents, which is from Hugging Face. Really, there's one in the Cloudera stack from Crew AI that also has code execution agents. The concept here is that you can translate the natural language, whatever it is, into some type of code. And in my case, I've just constrained that to be SQL that can be executed on whatever I've told it to execute. So some of this is mediated by the doc strings or other information that comes wrapped around the tool. Other things are just mediated by the transformer itself, by the LLM. So one thing that I ran up against is that, a couple of the different specifications for what my tables were and how they were structured, they were in disagreement. And the model was able to figure that out for me. So when you ran the Spark query, it actually returns the schema as part of the error. It says that these things do not exist in this form. And the model was able to, it did take an extra step. So, it does, nothing is for free. And so it'll try a few different times. And it finally gave up at generating SQL and just did a describe on the table because it was frustrated, I guess, that it wasn't getting the right answer. And then got the real schema and then was able to adjust the query and execute. So this is happening under the hood. And I was wondering why it took so long. So you look at the dialogue and you can see that you're doing like 8 or 9 iterations for every query instead of 1 or 2. Which is what, so I just go ahead and put a multi-agent thing in place and then it's able to learn about the scheme as it goes. And so it's very adaptable, very adaptive to change at the schema level, things like that. But if I were doing it from scratch today, I would probably have a control channel that lets me know when it's really kind of out of the normal operation. A couple of other things that I didn't put in the other slides. So OpenSearch and Quadrant, these are vector stores. They're pretty convenient, not just for normal RAG from pulling up terminology or something that is relevant to a conversation that someone is trying to have with the LLM, but it's also very good for huge footprints of many tables and structure that need to be referenced by these text-to-SQL engines. So you can imagine hundreds or thousands of tables, maybe having thousands of columns that change a lot over the course of a day or a week or a month. So all of that metadata information needs to also be retrieved and used to inform the execution of the agents and everything. So we have a couple of options there. And I keep Spark in the mix here because even on top of, we have Flink, we have all these other things that are just the plumbing to move events through the system. There's still the need to do some analytics on top of that might be bespoke, ad hoc, something is done to understand the data as it goes at the very end of the chain. And one of the things that you can do with that is just put online anomaly detection or other kinds of fast data analysis tools and things like that. So that can also be made available to the text-to-SQL agent. Thoughts? Yes.
You mentioned about OpenSearch, and also asked a question about the query to API.
Mm-hmm.
So OpenSearch has a Kibana kind of model that converts the queries, exposes them as a API with the ACL.
It does. So it's it's fundamentally built on Elasticsearch as a query API.
Yeah, but Kibana, OpenSearch has different name for the dashboard, I think, for the Kibana. So.
Kibana. Remind me what Kibana is. So
Kibana is the query, the interface for the database for the Elasticsearch.
But it also has additional features for log searching and things like that.
But log search is a different model, right? So that's all in the back. Kibana is the front end for all of those.
Got it.
So you query them from the Kibana.
Mm-hmm.
It has a ACL, or you query them, or whatever the query you make, and you expose those queries, and it's kind of you saying the results the different kind of gadgets or something, and you can expose that as an API.
Nice. I don't have any of that. Gadgets and widgets on top of log. I think that would be phenomenal. So I have pushed a little bit into getting OpenTelemetry integrated. So we're just seeing how the whole thing, whole architecture is fit together. and using OpenTelemetry as the means to pull information about the system itself. But I don't make any assumptions about the data going through the system being log oriented or maybe some other event thing. But it would be very interesting, yes, to build that layer on top of. And I use OpenSearch mainly because I hope I got the terminology right. I think it's OpenSearch. It's the vector capable search engine.
You can do ML. They have several models. It's everybody started supporting it. RAG vector.
Yeah, I can see how it would be very interesting. I just hadn't gone down that road yet.
I was just, it's a FYI.
Yeah, no, that's good. The big thing for me is that it supports hierarchical navigable small world algorithm on the index, the vector index, which is very useful. Apache Pinot actually has a vector index itself. So it could be that what you're thinking of, if I'm understanding you correctly, would be that using the OpenSearch capability as a way to search through the data that's flowing through the system, that the users put through the system. And I'm really just using, and right now, anyway, I think you have a good idea. I might want to take that idea. But currently, I'm using it as almost just a metadata. Like, tell me what's the data about my data and how it's structured. So the OpenSearch and quadrant part is actually pretty locked down. And I don't use that as a sink of the event data that's going through Flink. Does that make sense?
For a given, say, natural language query, if there are multiple overlapping indexes, does it pick one, or is there an aggregate on top of the indexes? Like, for example, if I'm asking for the cafes near me, it could either be like geospatial search or text search. So does it go through both?
So this is a good question. Okay, so if I understand you correctly, and this is true. So we have a number of different types of indexes that could be created from the data that's flowing through Flink. This is the. I'm trying. So we have, the question is, we have a few different types of indexes that could be created from the data that's flowing through Flink based on this natural language specification of what a feature in that stream should be. So end to end, that makes sense. But at the end of the day, we're going to have a number of indexes with various characteristics and query characteristics that get generated. And so at some point, the model, this text to SQL agent, will have to make some decision about how to best leverage the different indexes that are available to search. And so I think the question is, like, is there a router component or anything at this stage? No, there isn't. I haven't gotten that far. But the single text to SQL agent does a pretty good job of understanding what the different flavors of index are and selecting the different resources to satisfy even very generalized queries like do a time series analysis. Like very open-ended. And it says, oh, well, we have a time index. That's a good thing to do. But it might also decide to include stuff from a geospatial index and potentially try to cobble something together from those. It definitely needs, you would not start a company and put this anywhere valuable, but it's very interesting. A more rigorous implementation would have that routing with some deterministic logic probably about how different queries should be structured given the indexes. So, thank you. So just kind of recapping this, so Kafka, Flink, Unicorn, kind of mentioned all of those. So Apache Knox, so that is part of the stack. Knox is kind of a catch-all, and they call them topologies. But if you have any kind of applications in your cluster that are secured by Kerberos and need to be exposed to the outside world, Knox will be the kind of the gateway into those applications. So it's rewriting queries from the outside based on your login, able to access different APIs and interfaces that are within the cluster that you just have to configure your browser to speak Kerberos and jump through those hoops. Now out of the gate, Knox kind of handles that for you. And so when you put a new application into your cluster, you can configure Knox to be the gateway to that. So that's helpful here because we can do that with the Apache Pinot indexing and make that available from outside as an API or a source of information for some other component. Small agents I mentioned, that's what I just kind of picked off the shelf to implement this text to SQL. It's just one step above a hello world. Still pretty powerful, and just combine that with NCP. Through these, any more questions about at least these 4 types of indexing? So last time I was here, we were kind of at the early stages of building end-to-end automation to deploy everything. Now there's a bunch of people working on that project, and it's quite far along. I wanted to have something to kind of represent what this is. So this is Ansible Navigator, and that is running over here. So I did this earlier today. It's a single command. Once you do SSO login through AWS and get your credentials in the terminal, it takes about 45 minutes or so to deploy all the resources in the cluster. Reliably, repeatably. I'll get in there in a second and show you kind of what's in the box. But end to end, it sets up free IPA, Postgres, administrative databases, deploys all the secrets. Crucially now, it also deploys Knox, makes that the gateway into the cluster so that it's not open to the world. It actually can go through some authentication to produce a gateway to do the query writing and so forth. You've also included CSA, so that wasn't part of the standard stack originally. That's in there. Also data visualization, that's another one that's in there. And so taking the same concept and doing it with the open source components should yield a infrastructure as code, fully deployable thing. If I were to have the time, I would definitely have the inclination to do all of the security implementation as well. There's no magic getting from the open source free IPA and Knox to something to be fully secure end to end. Haven't undertaken that yet, but in this case, it is. So just go ahead and jump in. So again, this is internal to Cloudera, but at the end of the day, this is just a summary HTML page. It gets rendered locally, and so I open that in the browser, and it tells me what I've deployed in AWS. Let's see how slow the internet is here.
Excuse me. Did you say 45 minutes with the automation?
Yes. Internet though. Internet is killing the demo. Yeah, we might be too far from a reliable internet to do this.
I was just gonna
Oh, it didn't
say,
like-
if only we were so
I
far.
noticed the same as I had. That was interesting.
So Nathan, could you talk about the latency, why it takes 45 minutes?
There's an enormous amount of installation taking place. So you can see it's a decent sized cluster. It's designed to be relatively small. The different groups that are deployed here represent what's in there. So you have, I can't remember how much, all of the pieces to do high availability are there.
Do you want to try mine or?
I mean, if you can do a hotspot, I'll take it.
So is Ansible just being the orchestrator for the Terraform, or?
Correct.
It's got tutorial.
Okay. What's it called?
iPhone.
Quick, everybody.
Don't connect iPhone.
Cisco Ron, the name's meaning something.
Very
Just a wrong exclamation, bang. As soon as I moved it, the waters went down.
You need one more star in that picture.
I'm connecting. But the time is exclusively a product of how many things are being pulled down and installed. Each operation, like individually, probably only takes a small amount of time, but it's just a linear set of executions.
There are about 11 nodes in the cluster.
And I can pull that up. So. Maybe. I'm online with the minutes. Okay. Yeah. So, show hosts. Okay. So yeah, we do have a set of hosts here. You can see the different roles that are available. So we have Kafka, we have Knox, we have Ozone, we have Ranger, Solar, Yarn Zookeeper, Atlas, etc. So this is like a fully functioning cluster internally. We also have Knox. I've been talking for a long time. Sorry about that. So this is what I was talking about, topologies. These are just, it's a euphemism for the different applications that are in here. Data visualization, it's always nice to show the cluster to do things. A little bit painful with a lag. Sorry about that. If you can get this one going. So this is not open source, but there are very interesting alternatives like Metabase, for instance, that would be a great thing to use to connect to these types of outputs. So I'm considering what types of visualization tools I can put in the box. Another thing that I work with is Dask and HoloViews. If anyone has ever used that, that might be an interesting replacement, but very developer focused. Everything would have to be built by someone to make it work. The SSB again, you can see this is what we're intending to replicate with natural language. So this would be your assemblage of Kafka data sources, virtual tables, which we're using as the indexes and things like that. I won't bore you with free IPA and pgadmin. But is there any question about this automation piece? And I might do, actually. Does anyone have any questions about that before I destroy it? No?
It's huge.
All right.
So you're redeploying your cluster, is that what's going on?
Oh, I'm destroying it.
So you said this is internal, Ryan, to Cloudera, it's not public?
This is for now. My re-implementation is black boxed and be public.
Okay.
GitHub links at the end.
What kind of application are you guys using this framework?
What kind of application? Sorry, what?
Use case. Cloudera use case.
Cybersecurity is a good one for this stack. You can imagine telemetry. Cybersecurity is a very good use case. You can imagine telemetry coming from a lot of devices in the world. I used to work for a company called Automox. They do endpoint security as part of the CrowdStrike economy. So you could imagine all of the telemetry coming from hundreds of thousands of devices, or maybe just tens of thousands for a reasonable company. That would be all sources of information that can be pushed through Kafka. And you would want to dynamically create views on top of that information as it flows through your system. So you can create endpoints that might trigger alerts, facilitate investigations, drive like malware detection, things of that nature. Automox is very concerned about patching, so any thing that needs to be patched, that's going to be something you might want to build a stream around. So there's also this idea that you could potentially look for when a binary that is malicious becomes known, you could see when that binary may have been detected either by hash or by behavior or something in your cluster or in your real estate prior to it being known. So if you have some collection, some like repository of information that could be indexed with, Apache Pinot, you would then be able to run this query and say, okay, when did this bit of malware show up in my device? That'd be one use case.
Can you run like multiple streams and then enumerate the data, so you have like information coming in from your SIM and your vulnerability and your endpoint? But it's gonna be duplicate data. Will it index it so that you can tell it you can run queries so that it'll do that? See, I started using Cassandra for all my telemetry from cybersecurity.
And that's good choice.
Yeah,
What's the-
because the time that it takes to pull the entire row from SQL, it's gonna be faster in Cassandra. And then when you start stacking that milliseconds upon milliseconds on APIs.
So one of the things I like about Apache Pinot is it has you can do like hierarchical clusterings of data. So your indexes can be structured with a little more depth than you get in like HBase or Cassandra. I find. So it really would depend on your input telemetry, whether or not you can have a very simple mapping, CQL or what have you, versus maybe something where you might want to combine geospatial information along with some other kind of multi-dimensional index.
I like the geospatial for like being able to show vulnerabilities by geolocation. So that if you have, I don't know, like the DoD, for example, or VA hospitals, or a big company that has several business units, you can kind of see where they're located.
Where they're located, and I also use it for just geofencing. So devices that are in a certain area that are exhibiting certain types of telemetry, then that might need like a deeper look at something like even packet captures and things of the network infrastructure. If they're like
Can we do it by GPS and IP address?
I mean, if you put the GPS information in there, but I would just.
There has to be open source
Yeah, there is
GPS because Microsoft has it as a conditional policy for location. You can do it by GPS or IP address.
You gotta pay for the service, otherwise the IP map to the geo data is.
Yeah, so like MaxMind might be, how are you getting the GPS information? Is it being emitted by the device?
Yes.
So if you have it, then yes. Because the geospatial indexing would just have the, well, it has like the geometric query primitives. So if you can define like a fenced-in location in terms of geospatial coordinates, then you could get all the devices or events from that within that region. So like around the stadium, or on a corporate campus or something.
There is no open source data for taking look at geospace.
No.
You are paid, like
IP info provides pretty good information, and to a degree it's free. I mean, I check my private web server and it gives me geolocation. But it don't depend on geolocation because companies have virtual private networks, so you think it's in China, but it's not, or the other way around.
They use VPN.
Yeah.
I use VPN.
Yeah, but a corporate VPN is not gonna be in San Jose coming from China. I mean, you're gonna know what the VPN proxy location is to, I mean, this is going out to businesses, right? You have that information. My problem was when I worked in North Carolina and tried to order pizza at Cisco, it would always pull up San Jose.
I'll just try to zoom in a little bit. So I finally got myself relogged back in to Swap Networks. It's running, it's deprovisioning everything, tearing everything down. I'm only showing the tear down because the other one takes a lot longer. That's all. I'll start it redeploying or something, but it actually should be something, deploying all these services and everything should be something you do over coffee. It's very repeatable these days. So getting rid of like the 2-week manual exercise of getting everything connected and setting DNS and everything like that's over. It's even more over this year than it was last year. So this is, I'm considering under active development. So I have a repository that, again, I'll put on GitHub. It has the IAC components just for this project, deploying operators. I use like StreamZ, like again, open source operators for Kafka, Flink, Helm charts when they're available. Pinot itself is taking some work. It's a little bit tricky to get it deployed. Startree is a company that has a great Apache Pinot operator. I'm not using that, and so doing a little bit from scratch, I'll probably cut a few corners. But there's nothing fundamentally that's keeping me from using just a standard operator. Unicorn integration is also going to take a bit of work. So out of the box, it doesn't break anything, but it's going to take some work to be able to intelligently map, query resources and brokers and things like that into the appropriate resource management queues. I think that's going to take a bit of work. Open telemetry, again, it's fine to deploy the defaults, and it's nice that you can see telemetry flowing through the system, but there's overhead associated with that. So tuning that down actually to be very targeted about what we create, putting traces around, deploying the SQL to the application and everything. So getting all that intelligently structured shouldn't be too onerous, but it will take a week or two. And then I've been using DSPY for doing prompt optimization on top of the agents. So this is a Python library that will take a metric and some code that approximate what you want your agents to achieve, and will actually run
What's it called, what pie?
DSPY. This guy. So yeah, idea here being that you structure your code to represent your tasks that you want your agents to be able to perform, and you give it metrics for what success looks like in a series of examples. So in my case, I'm doing SQL queries, I'm pulling indexes, or pulling metadata and schema information and things like that, and I want it to reliably produce the intended result without getting like just thrashing on failure. So this program is pretty effective at building it. Small agents is a little bit strange in how it's constructed. The instructions for the tool are baked into a doc string in Python, but you can dynamically assign your doc strings with a _doc element. So I can actually build templates that can be hydrated when the Python is read in. It doesn't update like in runtime, but when it's first read in, it hydrates the tools with the appropriate schema information, table information, things like that. So that does imply you would probably have to do a restart at some point if your schema changes drastically. But the idea is you don't have to do the optimization process over. So I don't know how theoretically sound that is, but it works. GPU support, obviously that's important for being able to get this done. It's also important for the queries themselves. So rapids, things like that could be built into the system so that we could do like ad hoc querying and things like that. So we want to make sure that that's well supported. What that implies. That's about it.
So you mentioned that there may be some security applications, and I'm wondering, is there like a sequel to other query language translation going on here? A lot of folks don't know how to write SQL to an open search.
Got it. So we could try to do another demo here. So this project, it's called KD Upkeep, knowledge base upkeep, because eventually it will be continually, hydrating the knowledge base and the open search and everything. Right now, what it does well is exactly one small thing, which is translate natural language into a Spark SQL query.
Add this as an agent and you can query
So that's what it takes to take a natural language query and turn it into a Spark SQL.
Oh, I see.
So there's a coding agent that is deployed by this framework, small agents, that has a locked down Python interpreter. And so it can iteratively generate code, in this case SQL. It's not allowed to import random packages and things like that. So it's reasonably locked down. You can also have it run in a container for something that's like even more locked down. I'd like to develop a container that is almost like an avionics virtual machine that has extremely low-level controls on what could possibly occur within that container. In the meantime, use at your own risk, because it is generating arbitrary code and executing it in a real Python interpreter. So I'm intending it to generate SQL, but there's nothing to stop it from doing other things. And I have seen it generate nothing malicious, but arbitrary Python code to try to figure things out. So it's a really powerful capability, which is why it's so terse. The complexity is in locking things down and keeping it reasonably safe.
And you can create an entire REST cookbook from Python with AI.
Yep.
So is it really tied to Apache Pinot? Have you considered the alternatives, and if you have to replace it, how difficult would it be?
I mean, the easy option is going to be to keep materialized views. I mean, it's really simple, and actually a lot of the heavy weighted, cluster deployment stuff is because, you have a different service for everything, and they're all intended to be very large, scalable, and have failover. But I could really just do it all with Postgres. So if I really wanted to be small and think a very small footprint and very simple to operate and understand, it's maybe like on my laptop or something. I want to just do it all with Postgres. Use like Apache Age for graph capabilities, use timescale, use half a dozen, use PostGIS, geospatial, materialized views. Like you have really all the capabilities there in Postgres. So you're not going to get too far. And there might be other large scale like index providers or something. If you have any, I'd be curious.
I didn't know. ClickHouse being competitor to Pinot, right?
Is that ClickHouse like a Russian?
Yeah. And that's.
I'm sorry.
They rebranded a little bit.
I'm a cybersecurity person, okay?
I think they went through a process after Ukraine to reorient globally. And it's very smooth. I really like ClickHouse's developer experience because it runs really well on the laptop and scales well. and it just works great out of the box. I've actually used that as saying like, our stuff should be as easy to use out of the box as ClickHouse. So it should be just that, start the
But you're
process.
putting all of your
Have a cup of
back
coffee.
door,
Yeah.
in,
So,
I don't know,
These open source.
well, the technical reason not to,
right.
it's great, but the technical reason not to use it is that it does have trouble, I find it has trouble scaling beyond a certain number of nodes. One bit node. So I don't know if, I haven't gone deep enough in it to know if that's just because we're using it incorrectly, just a pathological use case, or if it's something more fundamental. Something like a Neo4j distributed graph search is technically, fundamentally, it's probably not going to be good for every kind of graph query. It's just the same issue with Atlas. So.
Well, I'll
Yeah.
tell you, the team at Cisco kept telling me they needed more hardware, so.
That's true. So I find that Pinot's more adaptable to kinds of problems that we have.
Apart from AWS, is everything free in the whole pipeline?
It will be. Yeah, it will be in these.
I wanted to get them.
And I would like to pull it all together. I don't want to pull from too many sources. I've decided it maybe has an umbrella project with like sub-modules or something, but the idea is to put everything in one place.
I have a question, I guess this is about Flink and Flink SQL, is that what it's called?
Mhm.
Is it possible to create a new source using Flink SQL? Like, is it like if my text prompt is, hey, get this data from this API or something like that?
I mean, anything is possible. I don't have anything to support that. So everything has to be going through Kafka already and pre-configured topics, and that maps directly into the SQL streams.
One last question. This is a big topic, so you want just a few lines maybe. Anomaly detection, what do you do?
Macro-based.
Okay.
I've used this one a bunch. It's nothing special comes up. Maybe it's so out of date now that it's so the company behind this is a Stanford spinoff. Hopefully this is the same source. It looks the same. So it was a Stanford spinoff. I can't remember the name of the group. But they created a company called Sisu Data that was acquired by Snowflake a couple of years ago. But this is, again, out of the box, runs on Postgres, does accelerated queries to essentially it's almost like a principal component analysis. So if you have some observed behavior, you can map back into the different components of your data that will result in that outcome. So it also runs on Spark.
For the entire flow from start to finish?
This would be for like a given, so you would want to use natural language to build a query that maps in a macro base. Otherwise, you just manually configure it. That's what I'm doing. So I have that as a separate component. The idea being that like, the outputs of that anomaly detection, I kind of know up front what I'm looking for, and those can become messages. Thank you.
Thank you, Ryan, for the great talk. Hopefully we'll start analyzing our streams tonight. Next month, we're going to talk on DNS, right? Guy, you're going to talk on DNS next month, right? Maybe.
If we have nothing else.
I think we're going to have DNS next month, so keep your eyes open for that one.
Unless anyone in the room wants to present next month.
Unless somebody comes up with something to present, yes. DNS is always fun to hear about, and I had some good knowledge about that long run. But
Look for the announcement.
look for the announcement. Keep your eye on the meetup conversation. Thank you everybody for showing up. Hopefully we'll see you next month. Still pizza in the back and drinks, and thank you for coming.
Thank you.